Okay, so now we're on chapter 4, section 4, and we're going to talk about the nomenclature of some simple alkanes. And when we say simple, this is actually an alkane that has some stuff attached to it. So anytime you have an alkane that is more than just carbon atoms all connected together in a single continuous chain, like we've been talking about so far, we call them branched chains. So you have a main chain, and then you have stuff coming off of the main chain. And so that's a branch chain. So the nomenclature rules, we want to make sure that when we name molecules, there can be only one molecule that names. Naming rules are pretty specific. And so anytime you're trying to name one of these alkanes, you have basically three parts to the name. At the beginning of the name, you're going to tell what kind of attachments are on the molecule. So we call those, in scientific terms, we call them substituents. So those are the little attachments. Those are the chains that are coming off, like what's coming off of that main chain. We're going to name that first. Then we're going to give the parent name. So the parent name is like, is it butane? Is it pentane? Is it octane, right? And then we're going to give it a suffix, and that'll be the family name. So it's because it's the alkanes. Okay, so let's look at the specific steps, and then we're going to actually do some. So remember, this is branch chained alkanes. We're going to find the longest continuous chain of carbons. And so in order to do this, right, you're going to have to count carbons and find the time when you get the biggest number of carbons. Then you're going to identify any of those substituent groups that are attached to the main chain. If they're just carbon and hydrogens, right? So we call them alkyl groups. And so remember how if you had like CH4, that was methane. Well, instead of having the ane in it, the ANE, we change it to YL. Instead of being methane, it's a methyl group because it's an attachment. It's no longer part of the main chain. Now it's an attachment, so we have to designate that. We have to say that. And that's how we do it, by changing the end of the name. Then we're going to give an actual number to the carbons in the parent chain. And we're going to have to start where we are closest to a substituent. So you might have to go back and renumber, and I'll show you what that means. And then we're going to say, okay, if I numbered my carbon 1, carbon 2, carbon 3, and on carbon 3, I had something attached to it, then I'm going to say, okay, that was 3 methyl, whatever it is, right? And if you have more than one methyl group, then you're going to use the prefixes di, tri. If you have 3, 4 would be tetra, and all that kind of stuff. But when we name it, right, we want to name our substituents in alphabetical order. And so I'm going to show you some examples, and we'll do some more examples in the problem set. But this example is in your textbook. Let's see, page 150. So I just pulled what the textbook has, page 150. So you can go and see this if you want to see it too. All right, so this is our molecule, and I kind of like it where I can see the color of the carbon atoms versus the hydrogen atoms. So it's just a little bit easier for me to view. So my first step is to count my longest chain of carbons. So what I do is I start at the ends, and then I count to the other end. And so there are multiple ways to do it, but let's start with this carbon right here. So this would be carbon 1, carbon 2, carbon 3. Okay, I can get 3 carbons in a row. Let's try another one. Let's try this one. 1, 2, 3. Oh, we still get 3. The only way that you can count it, the maximum number that you're going to get is 3. So let's go ahead and circle our main chain. So here is our main chain of carbons. So this is going to be step 1, right? So we found our longest chain of carbons. Step 2 is we're going to find our substituents. So I've circled my main chain. I'm looking for things that are attached to the main chain. I'm looking for a branch. Well, I see a branch right here. So I'm going to use the alkane name, and I'm going to change the N to LY. So this is methyl, THYL, METH, methyl, okay? So when I want to name this, I'm going to have to start thinking about the whole name. So I'm going to start with the substituents, that's methyl. But I have to say what carbon that methyl is attached to. So I need to number my carbons so my substituent has the lowest number possible. So if I were to do that, I could go 1, 2, and it's on the second carbon. Alternately, I could come from the other end and I could go 1, 2. It's still on the second carbon. So it doesn't really matter. It doesn't really matter which way that you go. You just need to pick the one that has the lowest number when you're looking at the attachment. So this would be 2-methyl. Okay. So I'm looking at, I have a parent chain that has 3, and remember, me eat peanut butter, right? So what is your 3? That is propane. So my main chain is propane. My substituent, S-T-I-T-U-T-A-N-T, substituent is 2-methyl. So now I need to look, what's my next step? I need to number my substituents based on their location. We did that, and list the substituents alphabetically. In this case, we only have one substituent, so we're kind of done with that. So this one I'm going to call 2-methyl propane. 2-methyl propane. Okay. All right. Now we're going to get a little bit more complicated. This is the methyl that we were talking about, right? I drew the methyl right here. That's the methyl. But what happens if you have more than one carbon, right? Remember, me eat peanut butter, right? Methane, ethane, propane, butane. Well, remember, if there are substituents, you're going to have to change that ANE to LY. So methane becomes methyl, ethane becomes ethyl, propane becomes propyl, and then actually this one's not, that one's not 4. I forgot that one's not 4. It's still 3. It's still 3 carbons, but instead of being attached at this first carbon right here, you're attached to the second carbon. So we call this iso because it's a variation of the propyl, so they call it isopropyl. So it's still propyl, but it's iso because your attachment's on a different carbon. So so be careful with that. So methyl, ethyl, propyl, and isopropyl. Okay, and so if you were looking at a structure, you might have to identify some of those, and we'll do some more later. So this is, again, from your textbook, and this is page 152. And so what we're going to do is we're going to determine the correct naming for these examples, right? And we want to follow those same steps that we were talking about. So the first thing I want to do is I want to find my longest continuous chain of carbons. And so I'm going to count my carbons from any of the ends. We can start at any end we want. So I'm going to start here, 1, 2. Now I could either go up 3, 4, or I could go the other way, 3, 4, or I could go 4 here. But if I start here, my maximum number is going to be 4. So let's see if we can get more than 4 going another way. So what if I start here, 1, 2, 3, 4, and then I could go here for 5, or I could go here for 5, doesn't matter. I'd have to pick one. So let's pick the top one. So let's say that this is my main chain. So I'm going to erase my numbers, and I'm just going to circle. This is my main chain of carbons. and I got 6 carbons. So if I have a 6 carbon chain, this is my parent. If I have a 6 carbon chain, I'm going to be pent, and then we have single bonds, so pentane, okay? Now we're going to have to identify our substituents. I have 2 substituents. And remember, if it's just the stick down is telling us that it ends in a carbon, and that carbon has hydrogens attached to it, right? And so we call, right, C, with just hydrogens around it, we call that methane, but we're a side chain, so we have to change the ane to ly. So this is a methyl, and this is a methyl, right? So let me erase this. So we have 2 methyl groups, and I don't want it to get too crazy, right? So we have 2 methyl groups. Just recircle that again, okay? So there's our 2 side chains, and they're both methyls. So if we have 2 methyls, now we need to be careful, because we want to number our methyls so that they have the lowest number possible. So if I did my original numbering, if I did 1, 2, 3, 4, 5, right? How did I do that? Did I do that wrong? 1, 2, 3, 4, 5. Pent is 5. How did I count 6? How did I count 6? It's 5. It's 5. Pent is 5. We have 5. Okay, I must have misnumbered. So you got 5. So now we want to make sure that those methyl groups have the lowest number possible. So if I did this numbering scheme, I would have 1 methyl at 3, and I'd have 1 methyl at 4. So that would be like 3 methyl and 4 methyl. But that might not be my lowest numbering. So I kind of have to go back and check. Maybe if I go from the other side, it would have a lower number. So let's try that. 1, 2, 3, 4, 5. Now when I do it, what do I have? Oh, I have a 2 methyl, and I have, oh, it's the same thing, a 3 methyl. So this gives me a lower number, and so this is what I want. So what I'm going to do is I'm going to list both places. I'm going to say this is 2, 3. And because I have 2 methyl groups, I have to use that prefix. I'm going to use di. So 2, 3, dimethyl. And then I have to name my parent, right? So that's 2, 3, dimethyl pentane. 2, 3, dimethyl pentane. Okay. All right. So let's try another one, and I'm going to try and count better. It's funny how you could do really complex things, but then sometimes you just can't count. All right, so I want to find my longest chain of carbons, right? And I tend to start on the left and just kind of count around and see what happens. I don't know why, I just tend to do that. So I'm going to start here. I'm going to say that's 1, 2, 3, 4. Now, which way can I go? I can keep going straight and I'll get to 5, or I can go up and go 5, 6. So that gives me 6 carbons. So I'm looking to see maybe if I start at another carbon, could I get more? Could I go 1, 2, 3, 4, 5, 6? No, that gives me the same amount. There's no other way to get more than 6 on this molecule. So I'm going to go ahead and circle my parent chain. So if I circle my parent chain, that's these carbons right here. So that's my parent chain. Whoa. I didn't even know it could do that. I could make it, to make it stop would be nice. All right, here's my parent chain. There's my parent chain. How is this stuff happening? It's like my iPad's going crazy today. Okay. And I see it up on the screen and I don't see it on my iPad. That's so crazy. So crazy. Okay, So now I want to identify my longest chain. So I said 6. So if you have 6, we want to make sure that we're numbering our parental chain so that we have our substituents on the lowest numbers possible. So let's find my substituents. Coming off of this carbon, I have a methyl group. Now coming off of this one, this is 2 carbons, so it's no longer methyl, it's ethyl, right? So my parent, oh, I didn't name my parent. Let me go back and name my parent. My parent, right, because I have 6 carbons. I really do have 6 carbons on this one. I have hexane, A-N-E, so I have hexane. And then my substituents, I know I have a methyl group, right? Remember to put that YL on there. And our other substituent, me-ete, so this should be ethyl. Instead of ethane, it's ethyl. And so we want to number the carbons so that our substituents have the lowest number possible. If you have 2 substituents, what you're going to do is you're going to look at the first letter, and you want to put the one that has the lowest, that has the earliest letter in the alphabet first. So you want to alphabetize it, basically. So if I do that, I want my ethyl group to have a lower number than my methyl group. So, so I'm going to count and try and give myself, let's see, let me try another color. So if this is carbon 1, carbon 2, carbon 3, 4, 5, 6. So that would give me my ethyl at 3 and my methyl at 4. And so that's what I want to have. So I would have, so this was at 3, this was at 4. So now all we got to do is put all this information together. So I have 3 ethyl. I have, and put dashes between them, 4 methyl. And then I need to name my parent chain, and my parent chain is hexane. Okay. So 3 ethyl, 4 methyl, hexane. All right, that should be a pretty good idea of how to do it. So now, in addition to having alkanes as side chains, you can actually have other atoms as side chains, and one of those is a halogen. So remember, a halogen is in group 7A, right? So right next door to those noble gases. And you see them a lot of times on alkane chains. And so we call these haloalkanes. Halo for halogen, right? Or you call them alkyl halides, but the basic is that it's a halogen, right? And so we name them, like fluorine, we call it fluoro. Chlorine, we call it chloro. Bromine, we call it bromo. So you're adding that O to it, right? And so the naming rules are exactly the same, except now instead of having branched chain alkanes, you have halogens being the substituent. And I'll do some like that in the little worksheet. And so the last set of substituents that you can have are cycloalkanes. And so cycloalkanes, when you name them, it's really similar to naming branch-chained alkanes, except you have a few little differences. So what you want to do first is you want to count the number of carbons inside the ring. So remember, cyclo is some of those ring structures that look kind of like that, right? And so you want to count the number of carbons in the ring. So I go 1, 2, 3, 4, 5, 6. I'm apparently on a 6 kick today. And we want to make sure that that ring, if we're going to call it the parent, that it has to have more carbons than any other substituent. So if you had a long branch chain connected to this cycloalkane, it's not really going to be a cycloalkane. It's actually going to be a branch, and the cyclo is going to be a substituent. So you got to figure out what's going to be the substituent, what's going to be the parent. So we number the carbons in the ring, and we look at our substituents, right? anytime you have only one substituent, you're going to make that carbon 1. If you have more than one substituent, one of the substituents is going to be on carbon 1, and then the rest will be on the lowest numbers possible, right? So we want the lowest possible combination of numbers when we talk about our substituents. All right, so, and if you have a ring and it only has one substituent, you can just name it and you can automatically assume that the 1 is there and you don't have to write it. So let's do a few of these. And these are on page, let's see, 154. Page 154, if you want to go ahead and see them. I'm just kind of walking them through. All right, so we need to first find, this is a straight chain. Well, it's a branch chain. We want to find our longest number of carbons. So I always like to start from the left. So I'm going to take a kick. I really am. 1, 2, 3, 4, 5. The other way I could go 1, 2, 3, 4, but that's not going to be high enough. So 5 is going to be my maximum. So I'm going to go ahead and circle my main chain. Okay, there's my main chain of carbons. And so if I have 5 carbons, so that's a 5 carbon, so the parent is 5 carbons. And so we call that pentane, because we have only single bonds, so it's an ane. And then we're going to identify our substituents. So if we look at our substituents, we have 1, 2 substituents here. So remember, if it's a halogen, so instead of saying chlorine, we say chloro, C-H-O-L, C-H-L-O, oh my goodness. C-H-L-O-R-O, chloro. Okay, and then we also have a methyl group, right? Methane, and then you change it to the YL. So now we want to number these, and we want to number the parental chain so that the lowest alphabetical has the lowest number. So C comes before M in the alphabet, so we want to give chloro the lowest number possible. So if I do that, that would be 1, 2, 3, 4, 5. So when I name this, this is going to be on the 2nd carbon, this is on the 3rd carbon. So I'm going to name it and I'm going to put it in alphabetical order, and I'm going to say 2 chloro, 3 methyl, and then the parent pentane. Okay. Let's try another one. Now this one's a little different. This one has a ring, right? So what we want to do is we want to count the number of carbons inside the ring and make sure we have more carbons in the ring than we do in the substituents. This one, the substituents is only 1, so it's going to be, we can automatically assume, but you should kind of get into the habit. So 1, 2, 3, 4, 5. Now, anytime I'm doing this, did you notice where I started my 1 at? I started my 1 where I have a substituent. Even if you end up being wrong some of the time on where exactly your numbering should be, it's a good place to start. Don't put a 1 unless you have a substituent there, right? You're less likely to have to change later. Okay, so then I know I have 5, right? But you have to remember that this is a cyclo, right? So this is cyclo, so you might see cyclo because it's in a ring, and we don't have any single bonds, so it's still an ane, and we have 5 carbons, so we're going to be pentane. Okay, so this is the parent. Okay, now we need to look at substituents. So when we look at substituents, we have 1 substituent. Our 1 substituent is methyl, right? Now, we can automatically assume, because we only have 1 substituent, that it's on the 1st carbon. So we don't actually have to write it. So this one we're going to name methyl. Let me T-H-Y, yeah, that's right. Methyl cyclopentane. Okay, so methyl cyclopentane. And using these nomenclature, you're never going to have more than one molecule with the same name. It's really cool. Okay, so we have another circle, but now we got a little bit of a longer chain. So we need to double check this. So let's count on our ring here how many carbons I have. 1, 2, 3, 4, 5, 6. Now let's count on our side chains. This one's only 1. Here we have 1, 2, 3. So we're okay. So we're going to keep our ring as our parent. So if we want to name our parent, we know that this is a cyclo. So it's going to be cyclo, C-Y-C-L, cyclo. And then because we have 6, 6 is hex. And then we have only single bonds, so it's hexane. So the parent is cyclohexane. And now we need to identify our substituents. All right, so here, this is just a CH3 group, so this is a methyl. And then we also have a 3 carbon, 1, 2, 3. So we know that 3 me eat peanut. So this is propyl, P-R-O-P-Y-L, propyl. So now I want to look at the first letter of each of them, and I want to put them in alphabetical order, right? So I need to put my lower, or one closest to A, on a lower number. So M comes before P, so M's going to be on the 1. We just so happen to get it right. And then P is going to be on the 3. If they were swapped, you would just have to renumber the inner ring, and that would be it, okay? So the methyl is on position 1, the propyl's on carbon 3, so we're gonna write that. 1 methyl, put our dashes in, 3 propyl, cyclohexane, okay? All right, and I think that was it. So we're gonna go do some practice problems, even though that was kind of already practice problems. I feel like it doesn't hurt. Okay, so we have our problems. So the first thing is we have to draw the condensed structural formula for each of the following. So, and these are alkyl groups. So that means that it's an alkane, but it's attached to a chain that's already there. Okay, so, and you have to remember the condensed structural formula. Whenever we're writing condensed structural formula, we're writing out the carbons and the hydrogens, but we're putting them basically in a line together. We're not showing any bonds. But in this case, we will show one bond, and that's to the R group. So that's the only bond that we're actually going to show. So let me explain what that means. Propyl, remember your little me eat peanut butter, right? Methane, ethane, propane, and butane, right? So prop is 3, so we know we're going to have 3 carbons. So remember, you're going to have some kind of a chain, right? It's not waves, it's a chain. But you're going to have some kind of chain, and it's going to have 3 carbons. So that's 1, 2, 3 carbons, right? So here's a carbon, here's a carbon, here's a carbon. This is the propyl group. So that propyl group is actually attached right here. And so when we write it out, we want to kind of say that. So I'm going to start at the bottom. I'm going to start with this carbon. This carbon is got 3 hydrogens attached to it. This carbon has 2 because it's bonded to the one below it. Then this carbon also has 2 because it's bonded to the one below it and the one above it, right? So when we write it, we write CH3, CH2, CH2, and then we say it's bound to the rest of the molecule. So we just kind of leave it like that. So let me just kind of scooch this over, right? It's not a negative sign, it's just saying that it's bonded to the rest of the molecule. So then methyl. Methyl is only 1, so all we have to write is CH3, and it's bonded to the rest of the molecule. Okay. Draw the skeletal structure for each of the following compounds. Now we're doing the reverse. instead of looking at a group and then drawing it, what we're going to do is we're going to start from the group. So when we do this, what I like to do is I like to start with the parent. So I like to go to the end and say, what's the parent? So my parent, let me do it over here. So my parent for A, parent is pentane. Pent is going to mean 5 carbons. So this is a 5 carbon parent. Then I'm going to come over here and I'm going to look at my prefixes. So 2,3-dimethyl. So what is that telling me? 2,3, it's telling me on carbon 2, ooh, sorry y'all. So on carbon 2, I have a methyl. And remember what your methyl is. Your methyl is the CH3 and it's bonded to it. So I'll just kind of put it in parentheses. And then my carbon 3, I also have a methyl. That's CH3 and it's bonded to the rest of the molecule. So let's go in and draw this. So I need first a 5 carbon chain. So 1, 2, 3, 4, 5. There's my 5 carbon chain. It's not beautiful, but it'll do. It's kind of wonky there, but that's all right. All right, so I'm going to go ahead and number these. You don't have to number them, but I think it makes it easier. But if you're turning it in, you don't want to have numbers on it. Okay, so C2 has a methyl. So I'm just going to draw a straight line, right? And then I'm done because I don't have to draw hydrogens because I'm drawing the skeletal structure. So remember, skeletal is bare bones. Okay, C3 is my methyl, and ooh, my 3 is kind of in the way. So then I'm just going to draw another stick like that. And so when I'm done, I want to remove my numbers, and that's what I'm left with. So this is 2,3-dimethylpentane. I kind of think it's easier to go from the name to the structure than the structure to the name. But okay, so I like to look at the parent first. So I'm going to look at the parent. Here's the parent. Cyclohexane. What does cyclo mean? Cyclo means we have a ring. And then hex is going to tell us that we have 6 carbons. Now I'm going to look at my substituents, right? So let's start from the beginning. 2, so that's a carbon 2. I have an ethyl group. An ethyl, remember, me eat. So that's the second one. So ethyl is 2 carbons. So it's like a CH3, CH2 bonded to something. Then I have at carbon 1 and at carbon 4, I have a methyl. So I have 2 methyls, dimethyl, right? And so that's just my CH3 bonded to the rest of the molecule. Okay, so I need to draw my ring. I have a 6 carbon ring. So a 6 carbon ring kind of looks, I'm not the best artist, like that. Okay, so we have 1, 2, 3, 4, 5, 6. Does it matter where I started numbering them? Absolutely not. Makes absolutely no difference whatsoever. You can do anything. I usually start at the top, but what if we wanted to go on the side? What if we wanted to do 1, 2, 3, 4, 5, 6? Doesn't matter. It's all the same because you can rotate it in 3 dimensions, right? Okay, so what am I adding? I like to take my carbons one at a time. So carbon 1, I'm gonna go and add a methyl group. So that's just kind of a stick. Then carbon 2, I need an ethyl. Okay, so I'm gonna come out, oh gosh, I was on a race. I'm gonna come out 1, and then you have to get the kind of, golly, kind of a, know that there's a second carbon, so you have to have a hook on it. So you could do it that way, or you could do it that way. It doesn't matter, it's the same thing. You're just showing that you have 1, 2 carbons, right? Okay, and then on carbon 4, I have a methyl. So there's my methyl on carbon 4, okay? So any which way you want to do it, and I guess that methyl should kind of be like that, but it doesn't really matter. Okay, So we got C. C. What is C? C is 1,2-dichlorohexane. So I want to talk about my parent. My parent is hexane. Whenever we talk about hexane, it's going to be 6 carbons, right? So that's my 6th carbon. Then I have 1,2-dichloro. So that means I have 2 chlorines. So that's on carbon 1 and on carbon 2. I have chloro, CHLORO, yeah, chloro. And that just means I have a chlorine attached. So a chlorine attached. It's not a negative sign, that is just a chlorine attached. So I'm going to start and make my 6 carbon chain. That's 1, 2, 3, 4, 5, 6. So I like to number them 2, 3, 4, 5, 6. I can always go back and erase. So on carbon 1, I have a chlorine. So I'm going to come up and end in a chlorine. Okay. Then on 2, I have a chlorine. And that's it. So I'm going to go in, erase my numbers, and I'm good to go. All right. Now we're going to go from structure to name. So this is the one I think is a little bit more hard. All right. So the first thing we want to do is find that longest chain of carbons. So if I want to find a really long chain of carbons, 1, 2, I could go 3 or 3, but that's going to end it. So I don't want to do that. 3, 4. So it looks like my longest chain of carbons is 4 carbons. So I'm going to circle my parent. Here's my parent, right? So I'm going to write that my parent is 4 carbons. And remember, 4, me eat peanut, butane, right? Now, carbon 2, we've never seen this before. Carbon 2 has 2 methyl groups. What do you do when you say it has 2 methyl groups on the same carbon? We are going to name this 2,2. It should be 2,2-dimethyl butane. Okay. So you're just putting them both on that one carbon. So you just say that carbon twice, 2,2-dimethylbutane. Okay. Next we have a ring. And remember, when we're numbering our ring, we're going to at least give our constituent the first number. So 1, 2, 3, 4, 5. So we have a 5-ring parent. That 5-ring parent, we're going to call Cyclopentane. So then carbon 1 has a bromo group. Bromo is just a bromine, right? But when we write it, we're not going to write the 1. So all we have to do to name it is say bromo cyclo, cyclo, P-E-N-T, pentane. Okay. Now the next one. Ooh, it's these that I think trip people up the most, just because it's harder to look at with all the hydrogens. It's easier to look at when you're just looking at carbons. So I want to find my longest chain of carbons, and I can come from any direction. I can come from left to right. If I start here, 1, 2, 3, 4, 5. I could have gone 4, 5, but that doesn't give me any more. I could go 1, 2, 3, 4. So the maximum I can get going that way is 5. Let's see if I can go another way and get some more. What if I start on the other end? 1, 2, 3, 4. I could end in 5, but that's not any different. I could go up. I could go 5. Aha, 6. So this is what I want. This is giving me my largest chain. So I'm going to erase my numbers and I'm going to circle my parent. This is my parent molecule here. Okay, so I got 6 carbons. So if I have my parent 6 carbons, that is going to be hexane. If I have hexane, now I want to look and I have 1, 2 groups attached to it. So I have it on, I have my 2 groups on, let's see, which carbon? They're both the same, so we're not worried about alphabetical. We just want to put them on the lowest number possible. So this could be 1, 2, 3, 4, 5, 6, or we could go 1, 2, 3, 4, 5, 6. So it would be a 2 and a 4, or a 3 and a 5. So we want the 2 and 4. Okay, so we're going to get rid of these blue numbers, right? Okay, so when we name this, we're going to say on carbon 2, we have a methyl group. And then on carbon 4, we have a methyl group. So I'm going to put all this together, and I have 2,4-dimethyl hexane. Okay. And I think, oh no, we have one more. No, that we're going to do in class. Okay, and that's it.